Good morning. If you're just joining us, we will be starting shortly. All right, good morning. I'm Jeff Hammond with IGSHPA. I appreciate everybody's attendance this morning. We have an exciting speaker, Lance MacNevin of PPI, and we will be turning the seminar over to him just in a few minutes. I have a couple of slides to go through. First off, this is our February Dig Deeper webinar on codes and standards. All right, so just a few updates here. We'll talk about our Dig Deeper webinars and town halls. We'll provide an update on the 2022 IGSHPA conference later in the year, and a reminder about renewals and CEUs. The town halls and Dig Deeper webinars are on the website. If you go to igshpa.org and click on the events menu at the top, all of those are listed. You can register for those as they come up. Also, if you note at the top of the IGSHPA website, there's an icon for our YouTube page, and that YouTube page has all of the recorded sessions from our town halls and from our Dig Deeper webinars. So if you want to review any of the past sessions, they're on that YouTube channel. It's a great way to review some of that information. Just a reminder, for 2022, we are partnering again with NGWA for our conference in December. It's in Las Vegas, December 6th through the 8th. If you go to the igshpa.org website, you'll be able to register for that. And we already have registration for exhibitors as well. You'll want to reserve your booth just as soon as possible in the IGSHPA Pavilion. As far as CEUs and renewals, we are no longer waiving CEUs for 2022. So if your membership or your accreditation certification expires this year, you'll want to turn in that CEU form. We do offer CEUs for the town halls and for the Dig Deeper webinars. If you would, send a chat message to IGSHPA. IGSHPA is listed as the host on this Zoom webinar. So just send a quick chat if you would like to have CEUs, and we'll make sure that that gets recorded. Just some housekeeping. Once I turn over the webinar to Lance, he'll go through his presentation, and I'll be monitoring the chat log. So if you would, please put your questions in the chat log, and we'll address those questions at the end of the webinar. If we don't get to any of the questions, we'll follow up with you later on. And if you would also please put your microphone on mute unless you're speaking. Just makes it a lot less disruptive for everyone who's joining us. We will be recording this webinar, as I mentioned earlier, and it will be on IGSHPA's YouTube channel once it's complete. All right, so we're ready to turn this over to our speaker. Let me stop sharing my screen and ask Lance to share his while I'm going through the introduction here. We're pleased to have Lance MacNevin with us today. Lance is the Director of Engineering for the Building and Construction Division at the Plastic Pipes Institute, PPI. He's been in the plastic pipe industry since 1993, involved with applications such as hydronic heating and cooling, geothermal, plumbing, and fire protection systems. Lance earned his IGSHPA accreditation in 2008 and has been closely involved with the geothermal industry ever since, with a focus on the piping materials used in the ground loops, including codes and standards. He serves on technical committees within ASHRAE, ASPE, ASTM, AWWA, CSA, IATMO, ICC, IGSHPA, and RPA. With that, we're pleased to welcome Lance and talk about this exciting topic. Thank you very much for joining us today. All yours, Lance.
Well, thank you, Jeff. Thanks a lot for having me today. Can you hear me okay?
Yes.
Very good. And is my slide showing properly, full screen?
It is. Thank you, Lance.
Okay, awesome. Thanks very much. So thanks everybody for joining. Glad to be here. Like I said, the presentation is officially called Demystifying North American Codes and Standards for Ground Source Heat Pump Systems. Talking about codes and standards, you try to do this at a party with friends or something, and pretty soon you'll find yourself maybe alone. It doesn't always seem like a really thrilling topic because there's a lot of patience required. There's a lot of steps involved, a lot of details required. But the typical IGSHPA audience probably everybody here in this webinar today, you're detailed people, you're technical people. So hopefully this is going to be pretty interesting for everybody here today, and maybe a little bit eye-opening to kind of revealing all the steps and processes behind updating codes and standards. You've probably written various product standards or building codes or geothermal codes over the years and said to yourself, who wrote this stuff? What were they thinking? And why don't they write this better? If you've ever found yourself in that position, today probably will answer the question, at least of who wrote this stuff, and then may also kind of open the door a little bit when you think to yourself, I could write this way better than they could. Well, then come on in and get involved. And we'll show you how to do that. So that's kind of the lay of the land in terms of what we'll be talking about for the next 45 minutes or so. And then we'll have time at the end for Q&A. Jeff read my introduction already, but I'm going to show it again because we are going to be talking about a lot of acronyms, a lot of industry names. So just in case you're not familiar with those, I'm just going to kind of spell them out a little bit. If you hear people talking about ASTM, that originally was formed about 100 years ago as the American Society for Testing and Materials. And that's a group that writes product standards. ASPE is the American Society of Plumbing Engineers, made up of about 6,500 people, most of them plumbing engineers. AWWA is the American Waterworks Association, that also develops standards for everything from products to installation to disinfection procedures. CSA is Canadian Standards Association, also known as CSA Group. IAPMO is the International Association of Plumbing and Mechanical Officials. That is a code developer that we'll be talking about today. ICC is the International Code Council, also a code developer. IGSHPA, we all know who IGSHPA is, and NSF is more properly known as NSF International, but they were originally incorporated as the National Sanitation Foundation. So if I do speak acronym a lot and use a lot of those things over and over, at least now you know what they stand for, or at least what they originally stood for. A lot of them don't really go by their full name anymore, like ASTM, they just go by ASTM International because their standards have been adopted well outside of the United States and all over the world. My contact information is shown there. As Jeff mentioned, I work for an organization known as the Plastics Pipe Institute. So just like IGSHPA, PPI, it's a nonprofit trade association. PPI was formed way back in 1950 in the early days of plastic piping systems by the pioneering engineers that developed these plastic pipe materials long before most of us were born, where they wanted to come up with some consistency and dimensions and test methods, because the question of how strong is this pipe, how long will it last, and how much pressure is safe? Those were common questions, and the engineers wanted some good, uniform, harmonized ways of answering these questions. So that's how PPI was formed, and then it ended up growing. Right now, PPI is based in Irving, Texas, with 11 full-time employees, serving almost every sector of the plastic pipe industry, with a focus in North America. Although we have global members from around the world, everything we really focus on is North American based. Our website is simply plasticpipe.org. And I work 100% for the division. We have 5 divisions. I work for the Building and Construction Division. That's our name. So we focus mostly on plumbing and mechanical systems, the piping materials that are used on the pressure pipe side of things. We have nothing to do with DWV systems, so we focus on plastic pressure pipe and tubing systems. And that big list of applications is shown here, everything from water service to ground source geothermal systems. The piping materials that we represent arranged alphabetically, starting with CPVC, which is a pressure pipe, HDPE, high density polyethylene. We all know that. That's the most common geothermal piping material in the world. PEX, which is cross-linked polyethylene, which is used for everything from radiant heating and snow melting, plumbing, fire protection, can also be used for ground source geothermal. PERT is polyethylene of raised temperature. It's a higher performance version of HDPE that can withstand higher temperatures. PEX aluminum PEX, it's a multi-layer pipe with a layer of PEX, a layer of aluminum, and a layer of PEX. Very popular 20 years ago in radiant heating and residential plumbing. not as much right now, but there's still some manufacturers of that product. And then finally, polypropylene, which is not flexible. Polypropylene is a rigid pipe joined via fusion. And there's two subtypes of PPR of polypropylene known as PPR and PPRCT. Each of those materials has its own webpage on our website. So if you go to plasticpipe.org/building construction, you can access a webpage just on each of those materials and a webpage all about plastic pipes for geothermal and lots of other cool stuff. We have nothing to sell. We're a nonprofit trade association. So all the information we provide is intended to be non-biased, representing the industry as best as we can. So this is our outline for today's presentation. We've got 6, let's say, chapters or parts to this. First, we're going to provide an overview of product standards and codes. That's kind of starting at the beginning. And then we're going to give some examples of product standards specifically for geothermal piping, so that everybody is very clear when we say a standard, so that you know exactly what we're talking about. And then we're going to introduce the model mechanical codes across USA and Canada with a focus on ground source heat pump systems. And then we're going to talk about how codes get updated. At one point, we'll also talk about how standards get updated. So again, if you want to help to revise those, there's lots of opportunities to do that. We'll talk a little bit about model code adoption across Canada and the US, showing some maps of where various codes are adopted. And then at the end, item 6 is just really one slide with a discussion about let's work better at trying to harmonize code adoption so that there's not a different code in the next county over or the next state over, because I notice many drillers today are probably working in lots of different territories, dealing with different codes every time you drive 50 miles. So it'd be nice if we could not have that anymore and have more uniformity in our regulations. So that's kind of how we'll wrap up, and then we can open it up for discussion. So if all that sounds good, we're going to start with section 1, which is an overview of product standards and codes, starting with product standards. So I don't want to read all these words on the screen. There's a lot of words in some of these slides. I apologize for that. We will make all these slides available. I'll email the PDF file of all these slides to Jeff as soon as we're done here today. I'll do it after in case there's any typos in here that I catch as we go. And then you'll have a good clean copy of all the slides. So there's no, and Jeff, we can do that, right? There's a way to share the slides.
Yeah, we'll actually have a recording of this presentation online. If anyone asks for the slides, then we can certainly provide those.
Okay.
Thank you.
Yeah, and they can email me directly if they want to as well. And I'm happy to just email the PDF. So, and I say that so that people don't have to try to scramble and write everything down here. So anyway, when it comes to product standards, so a standard is normally written for a product. So a pipe is a product, a heat pump is a product, and they have standards written for them. And the standards are normally written and developed by what we call standards development organizations, or SDOs. So if you ever hear somebody talking about an SDO, that's what that refers to. So some common examples in North America in this industry of SDOs are AHRI, ASHRAE is an SDO. They develop standards. Again, American Water Works Association, ASTM, CSA, NSF, and also UL or ULC in Canada. They all develop standards. And there's hundreds of other organizations that develop standards as well. But to be a standards development organization, you have to be accredited by somebody. We don't have to be, but you really should be, to make sure that the standards you're developing aren't conflicting with other people's standards and that they actually fill some sort of an industry need. So in the United States, every SDO strives to be accredited by ANSI, a new acronym. That's the American National Standards Institute, or in Canada, to be accredited by SCC, which is Standards Council Canada. And again, that's to ensure that they develop useful standards and in a correct manner. And by correct manner, that means you have to have diversity in the membership, diversity in the committees that are writing these standards. There has to be opportunity for public review so that when you're developing a standard before it gets published, anybody in the public has to be able to get access to it and view it and make comments. You have to listen to the comments. You don't have to agree to them, but you have to listen to them and address them one way or the other. and to make sure that the standards are approved through a proper approval process, such as balloting within that standards development organization. So there's a lot of structure required to be a standards development organization. So all the groups that do that are very well organized to be able to deal with these structures. From ASTM's own definition of a standard, it's shown here. So a standard, according to ASTM, is a document that has been developed and established within the consensus principles of the society and that meets the approval requirements of ASTM procedures and regulations. So they have, again, very well-defined procedures and regulations for developing their standards. So the purpose of standards, and this is probably repetitive for some people, so I apologize for that, but hopefully there's some new nuggets of information in here for you. The purpose of standards, really, normally what they do is they define a set of technical definitions and requirements. It could be for product design, manufacturing, testing, and certification. And the focus in all this is to protect consumers, the public, by specifying minimum requirements. They're not meant to be design guides. They're not meant to be limiting of innovation or anything like that. But they're basically to say for a plastic pipe, you get at least this much pressure resistance, at least this much temperature capability, at least, you're getting these dimensions for consistent dimensions. The information in the standards, as we'll see in a few minutes, comes from the people that are part of the committee writing the standards, who hopefully are directly related to the users, the customers, the specifiers, so they know if a standard needs to be updated. They get information from their regular day jobs, their work in the field, to be able to bring that information back for proposed changes to update the standards. People who make a product, like a pipe manufacturer or a circulating pump manufacturer or something like that, they're responsible to make sure that the product they make conforms to the standards. So if I was going to set up a pipe extruder in my basement and start making pipe, sure, I could invent my own dimensions, but it wouldn't meet any standard. And then nobody would ever buy it because it wouldn't meet any standard. And then the other important term to point out here is third-party verification or third-party certification. That's a really important term, because if I was making pipe in my basement, if I was making it in accordance with the standard, I could tell people, trust me, I've been making pipe for a year. Of course I make good pipe. Well, people might not trust me. So that's why I would want to go get a third-party certification. I'm the first party who's making the pipe. You're the second party who's buying the pipe, but the third party is an outside organization like NSF or CSA or IAPMO or other groups that actually will inspect my factory and do routine inspections, re-inspections, and test the product on a regular basis to make sure that the product is consistent and is meeting the standard. So that's a lot of information on one slide. Hopefully everybody is still here, because now we're going to move on to codes, and in particular building codes, which we're all pretty familiar with. A building code, it's a legally adopted document by a jurisdiction. So it could start as a document that somebody wrote or some committee wrote, but it really has teeth once it's adopted by a jurisdiction for the purpose of regulating a portion of the design and the construction industry. And you're going to hear the term model codes a lot, because these big organizations such as International Code Council and IAPMO and National Research Council in Canada, that's NRC, they write what we call model codes. They're not the law of the land until a jurisdiction adopts them. So I live in Virginia. Virginia regulators, the government of Virginia decides which code to adopt as the Virginia Building Code or the Virginia Plumbing Code. So normally they'll not try to write their own code from scratch in the state of Virginia, because it's pretty complicated to do that. The codes that have been around that are published today, many of them have been published for decades, 30, 40, 50 years. They're constantly being updated and refined and having new products and methodologies added, and always getting safer too. So it's much better for a jurisdiction to adopt a code that's been around for a long time, gone through 20 iterations to get to where it is today, as opposed to starting from scratch and writing their own code. We do find some jurisdictions do that route. They do write their own code. They may copy a lot of the information from a model code, but still give it a local twist. but really it would be way more efficient and probably safer overall if all the jurisdictions out there just followed a model code as opposed to trying to create their own, because whether it's plumbing or mechanical systems, they probably work the same in this county as they do the next county over or the next state over. So the organizations that write these model codes for construction, we call them code development bodies or code development agencies. And again, the examples that are most common in the US are ICC and IAPMO, and in Canada, it's NRC, based in Ottawa. And again, then when the model code or any model code is adopted through the appropriate legislative process for that jurisdiction, again, city, county, state, then it becomes the law of the land. The purpose of the building code is shown down below here. The codes specify the minimum requirements and standards for protection of public health, safety, and welfare. That's what their focus is, protecting the public. And the codes refer to standards. So you're not going to find dimensions for 3/4 inch pipe in a code. When it comes to what pipes are approved for geothermal systems, the code will say the pipe must meet ASTM standard 1234. I just made that up. That's not a real one. But they don't get into the detail of the products in the code because that's where they refer to standards. So it's really important that the standards are written and then the standards get referred to and accepted into the codes through a process. So that part is very important. On the enforcement side, if there's a code written, but nobody is enforcing it, if there's no building code department or inspection agency that's enforcing it, then it has no teeth and wouldn't get enforced. So, but most areas do have enforcement agencies, otherwise known as building officials or code departments, that will make sure that the codes are being followed for any type of construction, whether it's fire, plumbing, water, mechanical, or geothermal. But it also says if you're involved with code development, keep in mind, they're not intended as installation guides or best practices. Codes have to be written in mandatory language that says you shall do this or you shall not do that. You can go way beyond the code and do a much better job, but that's not the code's job of telling you how to make the very best, most optimal system in the world. It's the job of the code is to define systems that will work and that will be safe for the public. So that was our introduction, just 2 slides. Now we're going to get into some examples of product standards. So when we talk about standards, and I'm going to focus on pipes because I'm obviously a pipe guy and you people are pipe people too, because geothermal industry uses a tremendous amount of pipe. So hopefully this is relevant to everybody. So some examples of pipe standards, kind of alphabetically. The first one we have here is AWWA C901. This is from the American Water Works Association. It's a standard for polyethylene pipe for water service, all the way up to 3-inch diameter pipes. So it's really written for water service, but those are very good quality pipes with high pressure capabilities and everything else. So AWWA C901 is sometimes used as a reference standard for pipes that are appropriate for geothermal systems. Because if a C901 pipe can keep the water inside for many, many decades and is safe for potable water, it's probably also safe for geothermal systems. So that's one example. Here's an example from ASTM. ASTM standards always have a letter followed by 3 or 4 numbers. So D3035 is a standard for polyethylene pipe based on controlled outside diameter. So that would be OD-based pipe. So that is another standard. In Canada, we have our collection of CSA standards for plastic pipes. For the pressure pipes, they all start with B137 dot something. So the very first of those is actually B137.1, which was written decades ago, again, for polyethylene pipe and tubing and fittings for cold water pressure services. So that standard applies to water service, and water mains, and also geothermal piping. Geothermal piping is right in the scope of B137.1. There's a series of NSF standards that have been published over the last 10 years that apply to geothermal piping. And NSF 358-1 is NSF standard for polyethylene pipe and fittings for geothermal heat pump systems. And dimensionally, the pipes are identical to the pipes found in those other 3 standards we looked at. The pressure requirements are the same as the pressure requirements in the other three standards we just looked at. But what's special about 358-1 is the pipes also have to be certified and proven to be resistant to antifreeze products, such as propylene glycol and methanol. So the manufacturer has to go through some testing to prove that the pipes are compatible with those. We know they are. They've been compatible for decades, but now there's a certification process to prove that out. And then the final standard I'll include here, and this is not all of them, there's others, is NSF ANSI/CAN 61, short name NSF 61. And that's a standard that gets updated almost every year. It's drinking water system components, health effects. This is the standard and the test method to prove that a piping material or a valve or a fitting that touches potable water will not contaminate that potable water and make it unhealthy in any way. So it's a very elaborate test process, costs tens of thousands of dollars to have a pipe or fitting material certified to NSF 61, and it has to be retested at least once a year with surprise inspections of the factory and everything else to keep that certification valid. So that's kind of an introduction to 5 really common and important pipe standards. On this slide right here, we're providing a little more detail into Astm D3035. So these are not free standards. You have to pay for them and buy them. The organization ASTM, that's what they do. They develop standards and then they sell them. That's what pays for ASTM. But they're not very expensive, typically $50 or $60 to buy a PDF version of one of these standards. So if you do get a copy of D3035, and what, by the way, what I have on the screen is the 2021 edition, because they do get updated. Just for example, on the left-hand table 2, you'll see these are the different IPS sizes that are part of D3035, and then you'll see the actual diameters and the tolerances. So even if you just look at nominal pipe size 1 inch, where the outside diameter is specified as 1.315 inches plus or minus 5/1000ths of an inch. That's an incredibly tight tolerance. A piece of paper, it's about 4/1000ths of an inch thick. So the tolerance for outside diameter in a plastic pipe, it's almost as, down to the thickness of a piece of paper. Incredibly tight. Here is a table of some other dimensions for all the different wall types, meaning DR26, 21, DR17. The wall thickness is also specified in there, and all the long-term pressure testing and things like that. So there's a lot of detailed requirements in a product standard such as D3035 or B137.1 or the other standards that we looked at a minute ago. So tons of detail. Now, here's an example of a different product standard that's actually a system standard. And many of you have probably heard of this system standard before. The full name is ANSI, which means it's accredited by the American National Standards Institute, ANSI. CSA IGSHPA C448, Design and Installation of Ground Source Heat Pump Systems for Commercial and Residential Buildings is the full name. And the version shown on the screen is the 2016 edition, Series 16, which is the most recent and current edition of C448. C448 was around in Canada for more than 20 years, I believe. But about 8 or 9 years ago, a lot of people from the geothermal industry in both Canada and the US said, you know what, that C448 standard for Canada, it's not bad, and it's a good standard for geothermal, but it needs to be written in a different way to be adopted in the US. So a so-called binational technical committee was formed, mostly under the umbrella guidance of Mark Metzner, who put this team together starting around 2012, 2013. People representing all kinds of organizations on both sides of the border to put together a standard that could be adopted in both countries. So it was in accordance with the ANSI standards development requirements so that it could be adopted in the US as well. It's a very comprehensive document, very thorough, but it's also being updated. And we'll talk about that more a little bit later. But this is an example of something that starts out as a standard and then gets adopted as a code. So in Canada, we have the standard, which comes from CSA. That doesn't put it in the legislation anywhere, What happens next is the National Building Code of Canada, published by NRC, includes reference to C448 as the law of the land when it comes to geothermal systems. So starts as a standard and then gets adopted as a code, if that makes sense. And Jeff, this probably is a good time to talk about the next edition of C448, because Jeff Hammond, our IGSHPA executive director, is now the chairman of the C448 technical committee, guiding the development of the next version.
Sure, I don't want to take time away from you, Lance, but I can say a few words if that works.
Yeah, please.
And so we're currently in the process of updating the standard. We have a lot of feedback from the IGSHPA Standards Committee on changes to the standard to make it more binational, more friendly to the U.S. But we also have some additions. There's a new section on sewer waste heat recovery. We're looking at antifreezes. Lance is working on the piping task force. So we're looking at all kinds of new technology there, and just general updates. We're also moving some of the information that's redundant in the various sections to the general section. So that'll cut the page count, but it'll make it easier to use. So a lot of things going on with this edition. We're hopeful that we can have it wrapped up by the end of the year. We may hit fall if we're lucky, and then that would become probably a 2023 standard is my guess at this point. If we hit 2022, I'd be surprised. But we're making really good progress, and anxious to get that next version out there. Thanks, Lance, for mentioning that.
No, my pleasure, and thanks for your leadership on that. It's a team of very talented people working together. So anyway, back to the presentation. The next slide is on who writes the product standards related to ground source heat pump systems. So back to the pipes, or for example, the standards development organizations themselves do not write the standards. ASTM staff does not write ASTM standards. CSA staff does not write CSA standards. What their job is to manage the process according to their national guidelines, depending on which country we're talking about, and then to publish the documents, publish the standards after they've gone through all the steps of public review and approval and whatnot. So the standards, though, are actually created and maintained by the relevant technical committees within each SDO, if that makes sense. So for example, back to that ASTM pipe standard D3035, it's the responsibility of the ASTM technical committee known as F17, and in particular, a subcommittee known as F17.26, focused on olefin-based pipe. So this is getting into the weeds here a little bit. I know it's a very technical committee description. The scope of F17.26, that subcommittee, is to develop and maintain ASTM standards for pipe and pipe appurtenances made from an olefin-based polymer or any combination of olefin-based polymers. So olefin-based polymers are most of the polymers that are not vinyl-based polymers. So polyethylene and PEX and polypropylene and PERT, those are all olefin-based polymers. And if you actually had a copy of D3035, if you look in the footnote way down in the bottom of page 1, that actually tells you the specification is on the jurisdiction of subcommittee F17.26. And it even gives you the publication date and the original publication date. The fine print down below even says that standard was originally published in 1972, which I have to do some math here. That sounds like 50 years ago. That's how long that plastic pipe standard has been around. And within the committee structure of F17.26, as you can see by the second table that just popped up, it's made up of a combination of producers, people who actually produce the pipes, they work for manufacturers, end users, potentially there could be consumer members, and a lot of general interest members, meaning they're not the companies that make the pipes, but they have a use of the pipe or they deal with the pipe in some way. So the committee has a total of 217 members. This is as of last fall. So it's a lot of people working together to approve any changes. So any change that's proposed to a standard like D3035 has to go through a ballot process First to be approved by the 217 members of Committee F17.26, and then to also be approved by all the members of the big committee called F17, which is close to 400 members. So it's not easy to change a standard. You really have to make sure that you're technically accurate, not causing trouble, doing useful work, and doing things that are not controversial that will basically get the vote of others. Within CSA C448 that we just talked about, if you actually have a copy of C448, there's 4 pages near the beginning of the document that actually spell out who all the members of that technical committee are. So many of you are probably on this webinar right now. Thank you for your service on C448. It is a pleasure to serve with you on that committee because we're doing very good, important work there. Now, let's switch gears again and go back to model codes. We talked before about what is a code. Now we're going to show some exact examples of the model mechanical codes that do include content for ground source heat pump systems and include reference to CSA C448, believe it or not. So here's the 4 biggest mechanical codes across the United States. The 2 on the left are from the IAPMA organization. Again, that's the International Association of Plumbing and Mechanical Officials. IAPMA was based in Ontario, California. They have the Uniform Mechanical Code, which has been around for many decades. And the other code is called the Uniform Solar, Hydronics, and Geothermal Code. 10 years ago, that was just known as the Uniform Solar Code. In 2015, they added hydronic content, and then afterwards, they added geothermal content. So those are 2 separate codes. The Uniform Mechanical Code, it covers everything from gas piping and ducting systems, and it's probably 500 pages. The Uniform Solar, Hydronic, and Geothermal Code is probably closer to 200 pages of content. From the ICC family, we have the International Mechanical Code, which is focused just on mechanical systems, so it's analogous to the UMC. But then there's also the International Residential Code from ICC, which is basically the building code for 1 and 2 family dwellings, and then it has a subsection on plumbing and a subsection on mechanical systems. So sometimes you'll hear people talking about the IRC-M. The -M means the mechanical section of the IRC. So let's show a little more detail here. Within the UMC, the Uniform Mechanical Code, Appendix F is where you find your geothermal energy systems content. That is in the 2021 edition. All of these committees are constantly updating these codes, by the way, and working on the next edition, which we'll talk about in a few minutes. But it's already been decided that in the 2024 edition of the UMC, that what is now Appendix F in geothermal systems will be moved into the main body of the code as Chapter 17 or Chapter 18, which makes it more enforceable as compared to an appendix. Within the next code, which I call the USHGC, Chapter 7 is all about geothermal systems. Within the IMC, you have Section 1210, which doesn't get into a ton of detail on the whole geothermal system. It's really focused, probably pretty hard to read this, but what it shows under the IMC page view, it's for plastic pipe, ground source, heat pump, loop systems. So it really focuses on the ground loop piping is what's in the IMC. No specifications for the other part of the system, but it's really just about the piping. And then similarly with the IRC, when you find the section about geothermal, it's really focused just on the ground loop piping. So there is content in all of these codes, and they all refer to C448. So for example, for the International Mechanical Code, it was revised in 2021 with direct reference to ANSI CSA IGSHPA C448. So if you go to that code and you look in section 1210.8, under installation, it says piping, valves, fittings, and connections shall be installed in accordance with ANSI CSA IGSHPA C448 and the manufacturer's instructions. So in other words, if you're doing ground loop systems, you better get a copy of C448 and read what it says about how to put your ground loop systems into the ground, because that is a requirement in the International Mechanical Code as of 2021, which is just last year. Now, something else about code adoption we'll talk about in a minute If you live in an area that uses the I codes, they might not necessarily have adopted the 2021 edition yet. And there's often a lot of unfortunate delays. These code committees work really hard to update these codes every 3 years, but sometimes the jurisdictions that use those codes only adopt every second version, or maybe only every third version, which would mean only every 9 years are they actually updating the code that they enforce within their jurisdiction. And each jurisdiction they set their own rules in terms of when they're going to adopt a new version of a code. But these code development agencies are always promoting their new code as being better than the old one, and they are, and they would like to get them adopted as quickly as possible. Now, just like we talked about with standards in terms of how does the standard get revised, now we're talking about how does a code get revised. So like I said at the beginning, if there's language in one of these codes that affects you, and you've said to yourself, who the heck wrote that stuff? I could do better. There is a way of getting involved with all of these. So for example, IAPMO publishes a very detailed timeline and code development process. And they normally publish this as a press release. So all the trade magazines will include a link to this page. That's how I got it. So right now, the process is underway to develop the 2024 edition of the Uniform Mechanical Code. That's my example. And on their timeline, which is shown in the image on the right-hand side of the screen here, it's a simple 28-step process that takes place over about a 2.5-year period. And then you start all over again on the next code cycle. And as you can see, all the items in yellow have been completed, which means the last milestone on this timeline was that on January 4th of 2022, about 8 weeks ago, anybody that wanted to submit a public comment about what the committee agreed to in 2021, that was their deadline, was to submit a public comment by January 4th. So what happens is, in the beginning of this process, IAPMO will open up the website. Anybody who wants to submit a change, you do it online by a certain deadline. And then they compile all those changes in a document and give them to the code committee. And the code committee has a couple of months to read them, review them, and then the code committee gets together for a few days and discusses the proposals and then does a vote. Do we approve these proposals or not? And then the votes of the committee gets published. And then for anybody who doesn't agree with what the committee voted on, you have a chance to submit a public comment and say, we don't agree with the committee. Here's what it really should say, and here's why. That was the public comment deadline. The next step for the UMC is the committee is going to be meeting in early May. If you can read the image on the right where it says technical committee meetings from May 2 to 5, 2022, that will be an in-person meeting in Anaheim, California, where that technical committee will meet for 2 days on the UMC to discuss all the public comments and decide if they want to accept public comments or reject them. So again, a lot of details involved with the process. I'll try not to get into the weeds any deeper. On the ICC side, their code development process is similar to IAPMO's. It accomplishes the same goals. This is a document from ICC in terms of how their code development process works. And it looks like a circle because it is, because it's continuous. As soon as one version of the code gets published, let's say the 2021 codes published about a year ago, then there was the opportunity to start working on the 2024 codes. And that's what the committees are still working on within IAPMO. However, within ICC, they're actually a little bit earlier ahead of the process, and development of the 2024 ICC codes is mostly complete at this point, which is still 2022. So right now, anybody has an idea for a big change to an ICC code, you're probably going to be proposing it for inclusion in the 2027 version of the ICC code. So this is a marathon, not a sprint. You have to be quite patient and meet all these deadlines, make sure you attend all these hearings to speak to what your proposal was, defend it to the committee. You have to go up to the podium sometimes and say, I was the proponent of this. Here's why I wrote it. Here's why you should approve it. I'll answer any questions. Go through that kind of a process. Very formal. Robert's Rules of Order all day long. So those codes are kind of wrapped up mostly for 2024. The code is still open for business, though, and still open for proposals is the IAPMO code, again, the Uniform Solar Hydronics and Geothermal Code. This one is about a year behind the other IAPMO codes in terms of its development cycle. And right now, work is underway to develop the next edition of this one. And the submission deadline for proposed changes is March 4th, which, believe it or not, is actually next week. So it's coming up soon. Not to spring this on you at the last minute, the window for accepting proposals to the next code was opened way back last fall, I think in late September, early October. And IAPMO issued press releases about code development for this code opening up now. Now, one thing that IAPMO did do for the next edition of this code is they formed 4 task groups, and again, promoted those through public media and the trade magazines, and anybody could join. You did not have to be an IAPMO member to join one of the task groups. So for instance, I served in the hydronics task group, which had 5 meetings of that task group over the last few months. And I also served on the geothermal task group, which had 5 meetings over the last 2 or 3 months. In fact, the 5th meeting for the geothermal task group was just on Wednesday of this week. And that task group includes people who you probably know, like Carrie Smith, Jeff Persons, Roshan Ravankar, Jeff Hammond, all of us working together to try to, in a task group way, agree to new language before it gets officially submitted and submitted to the technical committee. The technical committee for this code will receive all these proposals in early May and will meet on June 21st at the IAPMO headquarters in Ontario, California. The first day of summer will be spent in their office reading all the proposals for the next edition of the US HGC. And I'm on this committee, so that's how I know some of these details. So if you're ever wondering again, who are the people that write these codes? That's not a secret. And in fact, inside the code book, inside the cover somewhere, you will actually find the list of all the different members. And the code development organizations, they try to keep it balanced. They don't want to have just a bunch of installers or just a bunch of manufacturers or anything like that. So they really do try to have a good representation of all the different stakeholders in the industry involved in one of these committees. So for the UMC, that's what's shown on the screen here. There's a bunch of different associations and some actual plumbers and some inspectors, users of the code. So it's a wide variety of people involved with the development of the Uniform Mechanical Code. And again, it's not a secret. It's very transparent if you have a copy of the document. All right, so now we're going to move into model code adoption, and we're almost done. Now we have some nice maps to look at. As I mentioned before, in Canada, CSA C448, it's actually already adopted in the National Building Code of Canada. So it is the law of the land. The current version of the National Building Code of Canada was published in 2015. So it refers to C448-12, the previous edition. When the next edition of the National Building Code of Canada comes out, it should be referring to the 2016 edition. Meanwhile, we're working on the next edition. And when the work that Jeff is leading to make the next edition of C448 is done, and that finally gets published, it'll probably have to wait a couple of years before it gets adopted into the National Building Code of Canada, which is supposed to be on a 5-year cycle. However, if you're working in Canada, in any province, any city, you could even lobby to have the newer version of C448 adopted, because it'll be probably much better than the current version. They normally are. In the US, if you go to the IAPMO website, they do have a web page that shows where their codes are adopted. Here's just a couple of screenshots of that here. This is not complete, but these are some areas where the various IAPMO plumbing and mechanical codes are adopted. And then if you go to the ICC website, you'll see a mechanical code adoption map that looks like this. It looks like the entire country, except for California, Maine, and Vermont, are using the International Mechanical Code. But the fine print down below says IMC administered at the state and or local level. So for instance, in Texas, it could be that just one county in Texas uses the International Mechanical Code. I'm not saying that's the case, but if one county or one city in Texas used the IMC, that would get it colored purple on this map. So it doesn't really mean that 99% of the country is following this one code. That's just the type how they gather their information to make these maps. And this is the International Residential Code, which looks like the entire country except for Wisconsin is using one residential code. But again, it could be just certain jurisdictions within the state are using the IRC. And then unfortunately, we have a lot of states or other jurisdictions that do this on their own. They don't follow the model code. They try to develop their own. And I'm sure a lot of you on today's webinar have run into this. A few years ago, the state of Minnesota opened up to listen to comments about its board geothermal heat exchanger program. So it's code for geothermal boreholes. And it was open to the public. Anybody could submit comments. But Ryan Sarda actually put together a good team of people from IGSHPA organization to review what the current Minnesota rules were coming from the Minnesota Department of Health, and then put together a document with proposed changes. So a big team of people worked on that for probably 4 or 5 months. Ryan submitted it on behalf of that team of people. And then ultimately the Minnesota group of officials that were that read the changes that were submitted by the group of people representing IGSHPA, they accepted about 25% of the changes that were submitted, far less than half. So it didn't necessarily go over really well, but that's the process in Minnesota. So if you want to change it, what you do is you try again, and you keep trying to change the rules. The problem though, with states that make up their own codes, let's say for geothermal, or counties or cities to make up their own codes, they could cite inappropriate product standards. And that could cause confusion with manufacturers and the supply chain and the installers. And this does happen a lot, even on the piping side, where they list the wrong piping standards. And then everybody who is trying to supply a system is like, what are they really looking for? I'm not sure what the requirements are here. So you could call those custom codes, and they often try to be a little bit of this, a little bit of that. They try to pull the best out of one code, the best out of another code to make their new superior code that works best for the state of whatever, which reminds me of the story of Dr. Frankenstein, who tried to make the superhuman being based on the head of the smartest person, the legs of the strongest person, all these bits and pieces from various people, where he tried to really create the best person. That's what some of these code creators try to do, but you know the story of Dr. Frankenstein's monster. It didn't work out well. That wasn't really what was intended. You should just allow the natural process to develop the most evolved species, or in this case, rely on model codes that have very defined, deliberate processes with lots of great experts from around the country to develop the best version of these model codes. So for everybody who's been involved with one of those situations where your local code isn't the same as a national code, and it's very restrictive and may even seem to be a little bit bizarre, we all feel that pain. And really the best path forward is my last slide. Let's focus on the single best code that we can put together as an industry. And then let's work really hard as an industry and a collection of associations to try to get that single best code adopted all over in Canada and the US. And I think that's what's going on with the work on C448. This slide starts with, why should harmonizing codes be this difficult? And it really is hard to change codes, no doubt about it. But heat works the same, no matter what jurisdiction you're in. Ground source heat pumps work the same, no matter what jurisdictions you're in. Modeling should work the same, no matter what jurisdiction you're in. Grouting should work the same, no matter what jurisdiction you're in. So having really a set of, one uniform code that has the best collection of minds working together on it in a deliberate process, as is going on with C448. I think I have a lot of faith in that process, being led by Jeff and Mark Metzner and many other subcommittee chairs and task force chairs. And I really believe that's going to develop an amazing code, probably the best in the world when it comes to geothermal systems. C448 is already excellent. it's going to get even better in the next edition. And that'll just simply benefit everybody involved in this industry, I think. So, but the big missing link then will be once the next edition of C448 gets published, it's just a document sitting on a website until we get it adopted as code in all the towns and counties and states and provinces out there. So that's where I think the whole industry is going to have to work together, probably on a grassroots level. It's not going to be super effective if me from PPI calls up Minnesota and says, we want you to adopt this code that we helped write. It'd be much better if contractors in Minnesota called their people who are their state employees and everything else and said, look, this is my state. We need a better geothermal code, and here it is. And that could happen, all over both Canada and the US. So with that, Jeff, my last two slides are really just summary of what we talked about, but we still have a few minutes left, not many, but I can stay on late, and I just like to open it up for a discussion if you want, to see if anybody has any thoughts or questions about all of this.
Thank you very much. Thank you, Lance. That was a great presentation. Lots of information there. I don't have any questions at the moment, but we will have this recording on our YouTube channel. If you want to review any of it, there's a lot of really, really good information in here. And I appreciate the time, Lance. Maybe in our last couple minutes, do you have any updates on new pipe technology or new products out there that you're seeing at PPI?
Sure. Well, for those involved with C448 or the other codes, one of the materials I mentioned earlier on, PERT, polyethylene of raised temperature capability. It's a relatively new product in North America. It is high density polyethylene that is capable of withstanding higher temperatures. And there are ASTM and CSA standards written for PERT now. So we're going to propose to add PERT as a new material into the codes. We're updating some of the detailed information about polyethylene requirements and PEX requirements. In the next edition of C448, the piping task force is working on actually putting in some good installation steps, good installation procedures for putting pipe in the ground, and a safer way to make sure you're not cutting it or gouging it, make sure you're not kinking it, make sure that you're not over pressurizing it in some way, from the inside out or the outside in. So we've been working on a lot of new content that way. Polypropylene is still a relatively new pipe material in North America. It's been around for 20 years here. It's been around for 40 years in Europe, but it's becoming much more widely accepted as a replacement of copper or steel for the indoor piping. Polypropylene, it's not flexible, but it's a great material for indoor piping inside larger mechanical rooms where you might have a lot of 4-inch, 6-inch, 8-inch pipes, things like that. So we've got tons of information on both those products on our website. If anybody has more questions, they can find it there or reach out to me and I'd be happy to share. We also have a collection of presentations, kind of like this one, on a PPI webpage that anybody can go access those and download those as PDF files and read all about those piping materials. Okay. So
very good. That's excellent information and perfect timing. It's right at 12:30 Eastern, 11:30 Central. I appreciate everybody's time. Hopefully you'll join us for the next town hall and dig deeper. And I wish everyone a great weekend. Thank you very much.
Thanks, everyone. Thanks, Jeff.